Day 3, Toboggan Trajectory. With the toboggan login problems resolved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in the area only grow on exact integer coordinates in a grid. You make a map, your puzzle input, of the open squares and trees you can see. For example, this block here. These aren't the only trees though. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. Alright, so it looks like up here at the top we have 2 blank, 2 full, a whole bunch of these. So it looks like this right here is where it goes 2 blank, 2 full, and a whole bunch of dots until we get to here. You start on the open square in the top left corner and need to reach the bottom below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3 down 1. For right 3 down 1. Okay, from your starting position at the top left, check the position that is right 3 and down 1. Okay, so that would be this one. And so on until you go past the bottom of the map. The locations you check in the above example are marked here with a 0 where there was an open square and an X where there was a tree. So I would go O, X, O, X, X, O, X, 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 until I get to the bottom of the mountain. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Okay. So starting at the top left corner of my map and following a slope of right 3 and down 1, how many trees would I encounter? Well, that's an interesting one. Let's go ahead and open up, our files. So what I have here on the left is my day 3 spec, and let me go ahead and zoom in so that y'all can see what's happening here. And on the right here, there we go, we'll go 150. And on the right here I have my class that I'm going to use in order to process all of my changes and all of my logic. There's some additional classes in the background that are happening that are in like a solution folder, like one of them is run, and it just grabs the file input and turns it into a series of things. Anyway, this is kind of an interesting one because the first thing I need to think about is how I want to store my map. I think that's going to be a big one, but also what I need to do is I need to go ahead and grab this. Oops, here we go. And I need to create my spec for part 1. So right here I have my process for part 1, and what I would do is I would say let input. Yeah, so I would say let input, and then I would add my curly braces here and pass this in as one big text blob. I think for these we're probably going to want something shaped a little bit more like that. That feels good. Yeah, that feels good. Alright, let's see. So I have describe class.run. I think what I actually want here is I want .new, and I want to pass in my input and the section of the puzzle that I'm on, or the part. Right, and we would expect this to equal, and it's already told us the answer for this one, right? Like if we traverse this map, we would end up with 7 trees. Yeah, 7 trees. That makes sense. I think, so I'm thinking about this, and I think creating this with an input and a part makes sense, and then processing it. But I think the other thing that we kind of need is we need like a method inside of process that handles what our slope is, right? Because our slope is gonna vary. I wonder which part of this I should handle first, right? Because there's like creating the map itself, and then there is the part where I handle traversing it. And I feel like creating the map is going to be a lot harder than actually traversing it. Thinking about this, I think, I mean, maybe we'll just make like a little 2D array or something. It kind of makes me want to like, it kind of makes me want to create an attribute that's like map, which I can do, right? Like I can just override, or you know what I can even do is I can just come in here and I can be like def generate map. And then I'd say at map equals, and so if I look at my at input, right, my input here is going to be this big blob. And I know I'm already splitting that input by new lines into these individual lines. That's happening over in my solution file. Let me go ahead and pull that up because it provides some helpful context. So I have like initialize here, and it's going to give me that input and part. It's going to have a process method that I'm going to override. And then right here what it does is it does array equals file.split and maps over that array and allows me to parse those lines. But in this case, I don't think we actually want to do that. I think we just want to leave parse line empty. And what we'll do is we'll say at input, and this is going to be an array. Well, I wonder if we can just operate on it as is. Because I'll have a string, and a string is an array of characters. So I can just treat it as an array of characters. So I kind of have one already, a map. I'm doing a lot of thinking and not a lot of typing. This is something I do sometimes when I'm kind of unsure where to start. I have an at input, right? Let's give myself a location. And I'm gonna make my location equal to 0, 0. What if I'm thinking about breaking this up into X and Y so I don't get confused later? Because I can see myself being like, okay, so now I want location 0, location 1. Am I looking for location 0 or location 1? Okay, maybe we just start by like giving ourselves a slope, right? What we're trying to do right now is we're expecting to get a 7 out of this. Let's see. And this is just like if I'm following a slope of right 3 and down 1. So we've got a fixed slope there, and we have no idea what the future is gonna hold. So yeah, I guess, do I know how long this is? How many trees would I encounter? So this goes to the right, but it doesn't go down, it looks like. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think what I can probably do is I can just say, wow. See, this is exactly what I mean. Location, am I looking for X or am I looking for Y? I think Y is going to be my second one, so while location 1 is greater than or less than at input.length. Yeah. Do this and then end. And I believe there's a do here. So we're going to take at input. So I guess what I do is I say at location, and then we're going to do the mutation. So that's going to be location 0. That's the first one. So that's going to be my x-axis, and that one was right 3. And that, this is not correct. This is going to be plus equals 1, and this is going to be plus equals 3. I bet you the next thing they do is they have me convert this to find what the path that is going to have the fewest trees is. And then what I do is I say at input, yes. I say at input at location 0. This is actually at location 1 because I want to get the index of my location in this. And then the next thing that I want to do is I want to say, okay, inside of that, give me my x, which is my at location 0. And then what I do here is I would say tree. I guess I would say if this is equal to a hashtag true, else false. Well, that already does it, doesn't it? So I would say tree equals this, which would work. So now this tree is true. And if this tree is true, I think what we want to do is we want to track the total number of trees, right? So this would be at trees equals 0. Tree equals this. Tree plus equals 1. By the way, I'm kind of sad that Ruby doesn't have a built-in, what's it called? Like plus incrementer. Okay, and then I guess what we do is we return at trees. Okay, well, does it run? It does not. Undefined method plus for false class. Uh-huh. Okay. Well. Oh. If tree at trees. That might help a little bit. Now let's run this. Undefined this for nil.nil class. Okay, you know what? I know for a fact that I have my pry. Oh no, wait. I should have my pry in solution, so I should be able to just binding that pry here. I think I'm gonna do it right here. So I can see what's happening. And if I'm going to binding that pry, I have to call this back from the terminal. So we'll just say rspec this. Okay, 2 examples, 2 failures. Did we not go into the y? Oh, undefined method pry. Oh, I don't have it in here anymore. Well, that's fine. I'll just add it and take it back out. So we'll do require pry, and now I should be able to run this. All right, let's try that again. There we go. That's more what I was expecting to see. Now, tree, false. I don't know where I am though. What's my location? My location is 3, 1. So I should be 1, 2, 3, down 1. And then what's my input? Oh dear. That did not split the way it was supposed to. Yeah, that's not what that's supposed to look like. All right. Let's just quit this. Nope, we can go ahead and exit. Like nothing is the way it's supposed to be there. What we really wanted over here was for this to already be parsed. You know what, I'm just gonna go up here and go control, nope, wait. Is it shift? No? Alt? There we go, it's alt. Alt, 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 alt. And the nice thing is these are all the same length. So I should be able to pop this here, come right over here, put quotes in, put commas in, and then just tidy up the ones that were kind of left over after all that. Yeah. All right, now I'm gonna save this. You're very upset right now. What appears to be the problem? You do not like this, because this is not an array yet. You know, I wouldn't like it if somebody passed a whole bunch of commas to me either. So I understand. However, I am going to need you to process this. Now that we've got all of this stuff set up. Let's see. Is it still fussing? I added the thing. Maybe it's not fussing anymore, but I just don't know that. Let's see, day 3 spec. Run. Oh, I have a binding net pry. Yeah, so that's not gonna finish as long as I have a binding net pry. So let's hop over to our terminal and we can just execute this. Let me see, what is my location? So this is gonna be my first location, which is 3-1. What is my input? And you know what I haven't handled yet? I haven't made this scrolling. So that's gonna be an issue as we start to get further down this map. What I'm thinking about doing is I'll just pop a modulo in there and I'll say like, hey, wrap around and go back to the beginning of the string. Let's see. So I'm looking at this. That looks good. Let's see. So 3, 1. Was that supposed to be a tree or not a tree? Okay, so here's the path. We start at 0, 0, we go 1, 2, 3, 1. Okay, so there's not supposed to be a tree there. There is supposed to be a tree at the next one. So if I go into this, I see, is there a tree? False. Excellent. Go to the next one. Is there a tree? True. Okay, this is feeling good. This is feeling good. I think I actually feel good enough to just exit, quit, quit, quit. Okay, let's just do a Control D there. There we go. Just, no, stop. No, stop. Quit. Q, Q, U, I, T. There we go. Now I can remove this binding net pry, save this, and then run this. Failed. Undefined method, this for nil class. Okay, where is that happening? Ah, that's happening because I haven't done the thing yet. Okay, let's see. So each of these should have a consistent length and width. So I think I just need to get that once. Like I can get input.length. Yeah. That feels reasonable. I almost feel like this feels like a method to me. Like def move. And we'll put an X, comma Y in there. And we'll just say tab. Okay, I like this. Let's do a map length equals at input dot length. The reason I like this is because it's going to make it really easy for me to figure out like what's happening, and it's going to be memoized. So we'll put that little or equals. What this does is the very first time it's going to call input.length, and after that it's just going to look at map length. And then we'll do map width or equals add input dot first dot length. Yay! Alright, so now that I have that, let's see, this is my X, correct? This is my X. So this one, what we want to do is we want to take location plus 3, and we're just gonna say modulo, what is my map width? And if you are greater than that, just roll over to the next one. Excellent. And then we'll just say at location 0. And this is one of the really, really nice things about having these class variable or instance variables, where it's kind of like the entire class has access to this, is that I can pull this move out into a method, and then I can just come over here and I can say move 3, comma 1, which I imagine is going to be really helpful when they ask me to make this different. Because I know they're going to ask me to like traverse this and figure out like what the maximum is, right? Like what is the best path? Yeah, that's reasonable. And this is plus equals y. This one we don't actually need to roll over, because as soon as we get to the end of that list, we're done. Like we're just gonna be done. So yeah, I think that should work. Let's run this and see what happens. Okay, undefined method this for nil.node class. Okie dokie. Let me do... I think I'm gonna need to put this first. Let's do a binding.pry. Yep. Oh no, not run. I actually want to run mu through RSpec. Okay, so what is my at location? What is my at location? 3-1. Yeah, somehow I doubt that's the problem. What is my at location? 6-2. That's to the right. Okay, I still don't think that's the problem. So let's go on to the next one. At location 9-3. And if I ask, is there a tree? What do you have to say? False. Okay, so you're fine. Maybe this is literally like... What? No, I want to quit. Okay. Maybe this is literally like the last location. So let me look at location. I'm at 5. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're gonna quit through a bunch of these. And then we'll check at location. At location. 2, 8. Okay, let me make some more space here. Let's see. At location. Quit. At location. Quit. At location. Quit. Aha! So yeah, it is the last one. It's literally the last one that fails. At location 0 equals this. Trees plus 1 equals tree. Let's see. So we're gonna finish this. I think this is just like an off by 1. Let's run it and see. Hey, it passed! Look at that. Isn't that lovely? Ah, that makes me happy. All right, so now we know that we have this working. I think now what we can do is we can run it against our input, right? So if I come over here and I take a look at this, give my puzzle input, Control A, Control C. I haven't made anything static other than my path and my move. So we should be good on that front. So if I hop over here, I just come over here to day3.txt, I paste this in, save it. And like I mentioned before, that solution has my run on it. So we'll say this is expected to equal 0. And then we'll run it and it'll give us a different answer. And the different answer it gave us is 207. That's a lot of trees. Hey, we got the right answer. Okay, and that didn't take too long at all. Excellent, so let's continue to part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Right 1 down 1, right 3 down 1, right 5 down 1, right 7 down 1, right 1 down 2. In the above example, these slopes would find 2, 7, 3, 4, and 2 trees respectively. Multiplied together, these produce the answer 336. What do you get if you multiply together the number of trees encountered on each of the listed slopes? What? how is that helpful? I thought we were gonna find the path with the fewest trees. Why would I multiply the number of trees encountered on each of the listed slopes? What? Okay. Sometimes we do things and we don't know why. I don't even. All right, so this was supposed to be 207, so we'll save that. Why would I multiply them all together? That's madness. All right, well, it's fine. It's fine. It's fine. It's fine. It's fine. Sometimes these things happen, and they just happen. I'm gonna take this out of a global variable. Let's see. It is expected that to equal. And the interesting thing is we could actually pass these slopes. 336. This is so bizarre. Why would you do this? Okay. Okay. It's fine. It's fine. Let's see. I'm gonna pull this down and I'm gonna make another method because I love methods. And I'm gonna call this trees per slope. And we're gonna have an X and we're gonna have a Y. And then I'm just gonna take this entire method, remove it, plop it in here. And what we'll do is we'll say if part 1 and we'll do at part. Then what I want to do is I'm going to do trees per slope 3 1. Else we would just say for and we'll call this slopes, and I'll come back and I'll add something in here. Let's see. Oh no, wait. What we actually want is like slopes dot each do slope end. There's a lot of toboggans in this year's advent of code. I guess we're just transitioning from place to place. Maybe there'll be some boats next. Anyway, trees per slope XY. Lovely. Let's see. We can do X, comma Y. And what I'll do is I'll just make a slopes here. And we can even make this slopes so it's static, and that means that it'll only get created once upon creation of the class, so you won't use up as much memory. Alright, so I guess we just like put all of these in here together. This is so bizarre. Why would you do this? Why would you multiply them? Why would you multiply them? What is it? I think it's like a dot reduce, and you can do, what is it? Ampersand colon star. And what this will do is it will multiply all of these values together. Slopes that each doesn't return an array, does it? It does not. Is map destructive? I'm trying to remember. Map to be, because if that is, let's see. Main use for map is to transform data. Array.map. Let's see. Ruby map examples. Yeah, but you don't tell me whether that's being returned from map or whether it's trying to replace map. Let's see. It doesn't collect the results. Each always returns the original unchanged object. but it returns a new array with the transformed elements. Okay, if it returns a new array, then that's going to be fine for us. Yeah, so we'll just do map xy, trees per slope xy, reduce, multiply them all together. Cool. Cool, 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 cool. Yes, with little commas in these. This hurts my heart. Why did they do this? Okay, so it's right one down one. So it's 1 1 3 1 5 1. Are they all one? Wait, 1 3 5 7 1. Ooh, that's kind of an interesting pattern. So it goes 1 3. Nope. 3. Let me get out of the way here. 5 7 1. The 1 is the only one with a 2, and the rest of them are with 1s. And I already see that I have a comma missing right here. And right here. Perfect. If I save this, what do I see? I see 1 1 3 1 5 1 7 1 1 1 2. Right? 1 2? 1 2. Yeah, 1 3 5 7 1 2. Excellent, excellent. This is progressing nicely. Okay, so we have at, this gets indented. At part 1 equals 1, trees per slope 3 1, slopes.map xy, trees per slope xy, reduce, multiply these together. When part 2, our input is going to be this one. So we can actually take this and we can make it the input for process. I like how they're using the same examples because it makes the test cases really nice and easy to write. Let's see, when part 2, it's expected to equal this. Sylvie? Okay, undefined method plus for nil.nil class. Nil.nil class, interesting. Where'd you get that? Okay. Okay. Let's see. Trees per slope xy. Trees per slope returns trees 0 plus equals 1 if tree. Oh. That's at trees. This just needs to be trees because that at trees no longer exists, so at trees was nil. Run! Expected 336. What did I get? Are you gonna tell me? No? Okay, that's fine. I'll just run it here. Ooh. Okay, so something is not working right. That's interesting. I think my next step here is gonna be to test trees per slope. Oh, you know what? I did not replace this XY. This is why I like specs. They basically tell me like you did something wrong. Okay, what we get this time? Okay, this way we got 4,802. So that's better. You know, it's not right, but it's better. Multiplied together, these produce 336. I still don't understand this whole multiply together thing. It's just weird. Like, who does that? Alright, so let's go ahead and we're going to make a new describe block. And this describe block is going to be for our slope method. Describe, do, end. Good. So I think before, what I kind of want to do is I want to, well no, I guess I just initialize it, right? I don't actually need to do anything inside of my process block because I'm just gonna come in here and I'm gonna say like describe class.new input part process. Except instead of process, I'm gonna be checking something else. And that something else that I'm gonna be checking is this method trees per slope. Excellent, so we come in here and we say, hey, trees per slope. That makes sense. And right here we say trees per slope xy. And we have some answers for this one, right? Like context. When x equals, you know, we can just do these slopes. When 1, 1. So 1, 1 should be 2. Let's see. When 1, 1, do end, and we would just say let x 1, and we'd say let y 2. And then inside here we would say it is expected to equal 2. Run it. What? Undefined local variable or method part? Oh, that's fair. Let's see. I guess the part doesn't really matter. That really only matters for process. We'll say let part equals 1. We'll be good to go. Run. Ooh, that passed. Okay. That one passed. How about our other conditional, which is 3, 1, and that should result in 7. Let's see. So we're looking for 3, 1 is expected to equal 7. I wonder if there's a problem with the trees per slope XY, or maybe the move XY? We're definitely resetting location before we run each trees per slope, so I don't think that's it. Run. It equals 7. And that's supposed to be 3, 1. And if I copy this, like, are there any of our trees for slopes that fail? 1, 2. Ooh, how does the 1, 2 do? That's the one that's kind of different from the rest. And the 1, 2 is supposed to be 2 trees. It is expected to equal 2. That one passed. Yeah, we can even see it over here. Also, I'm just gonna hop in here real quick, and I'm just gonna turn on enable auto run. There we go. So each time I change my spec file, it should run these. So that's passing. I wonder if it's worthwhile to add the rest of these, because I'm feeling very confident in this particular section of code. So let's see, 5, 1. Well, I've only got 2 left. We'll do 5, 1 and 7, 1. It's not that hard. 5, 1. Let's see. 7, 1. And then we'll have validated that all of these numbers are correct. And those are supposed to be 3 and 4. Let's see. 7, 1. You are supposed to be 4. You are supposed to be 3. You are supposed to be 5. You are supposed to be 1. Save these. Ooh. Expected 4. And did not get it. How exciting. When 5, 1 is expected to equal 3. And I got 7. What? When 5, 1 is expected to equal 3. Yeah, because this is 2, 7, 3, 4, 2. So 5, 1 is definitely 3. Well, that's interesting. Okay. Okay. The interesting thing about this is I can actually pry directly into this 5, 1, and I can see what's happening here. I think what I'm gonna do is I'm gonna binding that pry right here. Then I'm just gonna call it from down here, and I'm gonna call specifically this 5-1 that's failing, which is test number 86. All right, so if I take a look at this, what is tree? Tree is false, that makes sense. At input, at location, 3-1, 3-1. Wait, 3-1. I want to know how the rest of these passed under these circumstances. How, like, coincidence? What is happening in the world? I so do not care. Exit, exclamation mark. Be done with you. Okay, so that happened. You know what? We found that out very quickly thanks to our test cases. And because I turned on auto run, we know they're all passing. Except for this one. Yeah. And that's the one where we actually tested. I would really like to see what I really want to see what this was. Oh, got this. I don't know. That feels like a very large number, but I imagine that we hit an awful lot of trees. So is that right? Yeah! Alright, that's both of our puzzles today. Thank you so much for watching. Discord, leaderboards, all that sort of stuff. I'll see y'all tomorrow. Bye!